Hi, companions. Assuming you recall, in 2014, there was a blockbuster movie by Chief Christopher Nolan, Interstellar. In this film, space-related ideas like wormholes, dark openings, outsider planets were portrayed in an experimentally exact manner. Be that as it may, maybe the most stunning scene was toward the finish of the film. At the climax, the main character of the film, Cooper, falls into a dark opening. In the film, the name of the dark opening was Gargantua. Cooper falls into the dark opening with his shuttle. At first, everything was dark surrounding him, complete dimness. In any case, as he falls further, he sees some grain-like particles. These particles hit his space apparatus and cause scratches on it. There were a few glimmers of light, some flashes, and his space apparatus burst into flames. He had to eject from his space apparatus, and he continued to fall into the dark opening. Furthermore, out of nowhere, he wound up in a 5-dimensional space, a 5-layered tesseract. It was a staggering encounter where he could speak with his past self by utilizing gravity. Seeing these scenes, you could have pondered, is this really conceivable? Does this exist in a dark opening? If we fall into a dark opening, what will we see? Come, let's try to understand these perspectives in the present video. Dark openings remain generally obscure until the 20th century. A dark opening is a region in space where the power of gravity is so strong that not even light can escape. From an external perspective, you can't determine what is inside a dark opening. Dark openings torment our universe. Dim centers of gravity that swallow everything in their way. Einstein's hypothesis of relativity. Let's start with the beginning of this story, companions. The history of dark openings isn't very long. A long time ago, nobody had any awareness of dark openings. As a result of Einstein's hypothesis of relativity, dark openings were subsequently discovered. Companions, there are 2 parts to the hypothesis: the special theory of relativity and the general theory of relativity. The special theory of relativity, published by Einstein in 1905, tells us how speed affects time. If you are in a spaceship that is going extremely fast and the speed is too high, time will slow down for you relative to people not on the spaceship, back on Earth. The word relative is key, because when you are in a spaceship, you wouldn't feel the time slowing down. You would feel that time is flowing at the same speed as it normally does. However, when you return to Earth, you will realize that there was a difference in the progression of time. This is known as kinematic time dilation. What's more, gravity can also cause time dilation, as shown by Einstein in his general theory of relativity, developed in 1915. The more gravitational force you experience, the more time slows down for you. This is known as gravitational time dilation, and this was portrayed incredibly in Interstellar. When Cooper and his team land on the water planet, 1 hour on that planet equals 7 years on Earth. This happens on the planet because the planet was extremely close to the Gargantua dark opening. So, the gravitational force of the dark opening affected time. To visualize this, Einstein wanted us to imagine a space-time fabric, like a grid on which all planetary objects are set. The space-time fabric bends because of the mass of the objects. And when the fabric bends, not only does it attract physical objects more, but it also leads to time dilation. Additionally, different forms of energy like sound, heat, or light are affected by gravitational energy too. Yes, that's right. This was another conclusion drawn by Einstein. Gravitational energy affects nearly everything. Not only are physical objects attracted by the force of gravity, but it also attracts heat, sound, and light. Companions, this means that there can be such objects in the universe that have such high gravitational force that they can completely absorb light. If such objects exist, it means they would be completely dark. We wouldn't be able to see them because not even light can escape from them. Companions, this is exactly what dark openings are. However, when Einstein introduced his general theory of relativity, the concept of dark openings was purely theoretical at that time. Einstein knew that gravity affects light, and hypothetically, objects that can absorb light were possible. However, Einstein didn't know that real dark openings existed. In fact, during his lifetime, the concept of dark openings seemed bizarre to him. He knew that things like this could exist hypothetically, but then, hypothetically, the existence of infinity was also possible. But, fundamentally speaking, he didn't believe that such things existed in reality. When he died, not even the term dark openings had been coined. An interesting fun fact here. A central issue in Einstein's theory was that light speed limits gravity's effect. We don't feel gravity's effect immediately. Its ultimate limit is the speed of light. To use a practical example, suppose the sun vanished suddenly. As you may know, we'll find out about this 8 minutes later on Earth, because it takes 8 minutes for sunlight to reach Earth. However, according to Einstein, the gravitational effect of the sun's disappearance would also be felt 8 minutes later. Isn't it fascinating? After Einstein, the general theory of relativity was worked on by many scientists. There were some conditions. They solved those conditions and tried to infer the solutions. By solving the equations of these situations, it was theoretically demonstrated that objects like dark openings do indeed exist. By the 1960s, scientists and researchers had finally agreed that, not just theoretically, but one day, we would be able to see dark openings because they do exist in space. The term dark opening was used for the first time by a magazine in 1964. However, it was only after 1967 that the term gained popularity when physicist John Wheeler advocated for it. How are dark openings formed? Although the term dark opening sounds very shocking, it is a misleading name. Dark opening may seem like there's a real opening there, but that's not the case. There is no hole in space. Dark openings are formed by stars. There is some material at their core. But in stars, even our sun is a star, there's a continuous nuclear fusion reaction at their core. These reactions produce heat and light. The heat being produced sends an outward force, and at the center of the star, there's the force of gravity. This helps the star stay intact and alive. This is how stars maintain balance throughout their lives. The outward forces from the reactions and the inward forces due to gravity. However, these reactions occur when fuel exists, either hydrogen or helium. The fuel doesn't last forever. Eventually, the fuel will get used up, and when the fuel runs out, there will be no outward forces to counteract the inward gravitational force, so the star will collapse under its own gravity. This process takes a long time, by the way. Our sun's future is around 10 billion years. What happens next depends on the mass of the star. Let's look at the outline of a star's life cycle. Life cycle of a star. If the mass of the star is not high, i.e., if it was a small or average-sized star, it transforms into a red giant, after which it can turn into a planetary nebula or a white dwarf. But if it was a massive star, a star with a lot of mass, when it runs out of fuel, it cools down and transforms into a red supergiant. Then the supergiant explodes and transforms into a supernova. After this, a tiny core remains. If the core is small, it is known as a neutron star. However, anything larger than that is called a dark opening. Fundamentally speaking, the mass of the star, after it implodes due to its gravitational force, becomes very small and dense, and it can turn into a dark opening. Specifically, how small is the volume of the collapsed star? For a star as large as our sun, if it transforms into a dark opening, the diameter of that dark opening will be just 50 kilometers. Can you imagine the volume getting this small? However, the interesting thing here is that our child, the sun, will not grow up to be a dark opening. This was demonstrated by an Indian-American astrophysicist, Subramanian Chandrasekhar. He developed a limit value. He said that the maximum mass of a white dwarf can be 1.4 times the mass of our sun, above which it can't be stable and would transform into either a neutron star or a dark opening. However, since our sun is below this limit, it won't turn into a dark opening. Now, let's understand how dark openings are. There are essentially 3 to 4 types of dark openings, companions. The first is the stellar black hole. That's the most common type of dark hole. The dark holes formed by stars. Scientists estimate that in our Milky Way galaxy, there are anywhere between 10 million to 1 billion such dark openings. Then, there are the primordial dark holes. These dark holes are as small as a particle. However, their mass is like that of a mountain. It is assumed that they are about as small as a particle. These dark openings are purely theoretical, speculative, and we have very little knowledge about them. The third type of dark opening is the supermassive dark opening. These dark openings are massive, so huge that their mass is more than that of 1 million suns consolidated. Furthermore, it squeezes into a ball whose breadth is actually that enormous of our planetary group. Researchers trust that at the focal point of each and every significant universe, there is a supermassive black hole. The supermassive black hole at the focal point of our Milky Way galaxy is called Sagittarius A star. Also, the black hole in the film Interstellar, named Gargantua, was supposed to be a supermassive black hole. Furthermore, researchers believe there might be a fourth type of black hole as well. However, it can't be said without a doubt. The fourth type of black hole could be an intermediate black hole, which lies somewhere between the sizes of stellar and supermassive black holes. Although no verification of it has been found yet, one thing that you have found in the film Interstellar and in the photographs that you have seen till now, and your understanding of them, is that the black hole isn't similar to a big vacuum that sucks everything around it. Black holes appear to be this way. This is the black hole as displayed in the film, because it is in HD and more three-dimensional than the photograph captured by us some time back. The first thing that you'd see in this photograph is the orange-hued ring that forms around the black hole. It is known as the accretion disk. It is a significant feature of black holes. As you probably are aware, the gravitational pull in black holes is extremely high. So, because of the gravitational pull, a lot of gaseous matter and debris is drawn towards a black hole and stays floating around it, like how the planets rotate around the sun, in view of the sun's gravitational power. The thing that matters is that the gravitational pull of black holes is so strong that the things rotating around it rotate at an extremely high velocity and get so heated up that they transform into a flowing liquid-like matter. They literally become fire-like particles. The brilliant ring around the black hole is more than 1,000,000 degrees Celsius. The closer they get to the black hole, the faster they spin around it. The particles spin so fast that they get scoured together and compacted, which makes them begin to shine. They emit electromagnetic radiation, which are essentially X-rays. This accretion disk was portrayed precisely in the film. The main thing they got wrong was that it isn't really orange. Human eyes can't see X-rays. X-rays lay outside the range of visible light. We just represent it in an orange-yellowish color, so we can visualize it. The actual color of this disk would be closer to blue. In 2019, the first photograph of a black hole was taken. Even in this, the yellowish-orange tone was used to represent this accretion disk. One thing that you can clearly see in the genuine photograph that you probably won't see in the film is that the particles on one side are brighter than the opposite side. There's a simple reason for that. The particles turning towards us appear to be brighter to us, and those turning away from us appear to be dimmer. This is because of the Doppler shifting effect. When you look at the genuine photograph of this black hole, you can see this darkened photograph and interpret the direction of the spinning particles. The region that is brighter is coming towards us, and the faint region is moving away from us. Returning to the picture from the film, another interesting thing that you'd see is that the accretion disk emits an optical illusion because of gravity. It causes it to appear as though the disk covers the top and lower parts of the black hole. It seems like this because gravity bends a light. The region hidden behind the disk, when seen from the front, has its light bent by gravity. If you look at the black hole from the top, they will appear to be a normal, round circle. We get this illusion only while observing the black hole from the sides. Aside from this, when you enter the black hole, you will see a final circle of light. It is the photon sphere. The gravity in this space is so strong that the light begins circling the black hole. What does light consist of? Photons. The photons begin circling the black hole. This means that if you reach this region of a black hole alive, seeing the back of your head is theoretically possible, since the light is going all around in the shape of a ring. After this point is the limit of the black hole. This is known as the event horizon. It is considered a limit because after this point, the gravity is so strong that even light can't escape. Everything is dark beyond this point. If you are falling into a black hole and you have crossed the event horizon, theoretically, there's no way of you getting out. While possibly not even light can escape it, how could a human? In the film Interstellar, it is shown that Cooper's spacecraft keeps falling into a black hole, crosses this event horizon, and then suddenly reaches a 5-dimensional space. This part of the film is purely imagination. It is a theory since we don't know what will be at the center of the black hole. Einstein's general theory of relativity tries to describe this. In this theory, the center of the black hole is called the singularity. Singularity is the region of a black hole, the middle where the curvature of space-time is infinite. Do you remember the grid I discussed in the first half of the video? The heavier the object, the more the grid of space-time will bend. In the case of a black hole, this is bent to such an extent that it stretches infinitely. As we know from the theory of relativity, time, energy, and everything else are affected by gravity. With the increase in gravitational force, time continues to slow down infinitely. What if you fall inside? But what does it mean for time to get slower infinitely? Does this really mean that if you go inside a black hole, and if you ever could come back, the universe outside could have ended by the time you return? We don't know. We can only make speculations. What do you think? Comment below and let me know. There are some interesting theories that are suggested, like we can't see inside a black hole from an external perspective because the light is absorbed by it. One theory says that inside the event horizon, light bounces off at many points before reaching the singularity. So, it is possible that inside the event horizon, things would actually be visible. The only photograph we have seen for sure about black holes is this single one. This photograph, taken by the Event Horizon Telescope on April 10, 2019, demonstrated the presence of a black hole practically around 100 years after they were demonstrated theoretically. One thing is certain here. If you fall into a black hole, the odds are good that you will be torn into pieces due to the gravitational force. You will die in milliseconds. However, all things considered, friends, there is no need to be scared of black holes. Earlier, many people had this misconception that black holes suck up all matter, continue to get bigger, and eventually they will end the entire universe. However, that's not how it works. As I told you, at the center of every galaxy, there is a supermassive black hole, and all the remaining planetary bodies and stars in the range of the black hole spin around it, just like how all planets in our solar system spin around the sun. Exactly the same thing happens at the center of the galaxy, but in a much more impressive way. As a conclusion, if you avoid a black hole, if you maintain social distancing, you will be completely safe. And the concept of 5 dimensions mentioned in Interstellar is another fascinating idea. We'll discuss it in a future video. That's it for now. If you enjoyed this video, you can watch more space-related videos, including the one on time travel, if you haven't already. These concepts are explained in detail there. Thank you kindly.